let's define standard enthalpy of formation. So that is change, okay, change in enthalpy that accompanies the formation of one mole of a compound from its elements with all substances in their standard states. So that's enthalpy of formation. Now for a compound, and for a gas, pressure is exactly 1 atmosphere because it's standard state. 1 atmosphere. For a solution, concentration is 1 molar. And for element, oops, okay, again, okay, I need to stay away from this sign. Okay, for element, you can say at 1 atmosphere and 25 degrees Celsius. So that's their standard states. Now, let's see how do we solve for standard states. I'm going to give you an equation and then we'll follow one example. So these are their standard states. Now let's say, how do we calculate delta H0 for the reaction? I'm going to write Rxn for reaction. This is delta Np, number of the moles of products, and delta HF0 for products minus delta Nr reactants, delta HF0 reactants. So that's the equation we follow in order to calculate delta H of the reaction from their standard enthalpy of formation. Now let's work on one of the problem. Okay, let's say we need to calculate delta H0 for the following reaction. What is the reaction? 2 moles of Na solid, 2 moles of H2O liquid, 2 moles of NaOH aqueous, and H2 gas. Now for that we will be given following information. What the information given? Standard enthalpy of formation for Na solid, which is 0 kilojoule per mole, and we are talking about their formation HF0. That's standard enthalpy of formation for sodium solid. H2O liquid, which is negative 286, again it's kilojoules per mole. For NaOH aqueous, it is negative 470 kilojoules per mole, and for H2 gas, it's 0 kilojoule per mole. Now remember, we need to follow this equation, right? Number of the products, we have 2 moles of NaOH, so we said 2 times negative 286, right? Because we have 2 moles. Number of the moles of product times its enthalpy of formation. Now for the products, we have this 1 mole but 0, right? So we add them first for the products and then reactants. I'm going to go to next slide and we'll work together. Or yeah, we can work, or let me erase this part so we can work on it. You know that H2 gas is 0 kilojoules per mole, right? So let me go over in here, this part. I'm gonna clear up kilojoules per mole so we have enough information. Okay, now we have products. We have 2 moles negative 470, that's for NaOH, right? Okay, 2 moles for, and then 0 for H2O. That's for products. We are following this one. Minus,
what is 0 for, please?
0 for H2O, H2 gas.
Oh, H2.
Okay. Now we have reactants 0 for sodium and 2 moles of H2O liquid. So 2 times negative 286. And now we need to solve this. So when you calculate delta H for this reaction, you get negative 368 kilojoule. So you calculate delta H of this reaction using standard enthalpy of formation, products minus reactants. And remember, whatever the number of the moles, you multiply